Hello, everyone. Thank you for joining us today for episode 3 in the Bringing Your Containers to Azure series. Today's session is automating your container builds with GitHub Actions. Before we start, I just have a few quick things to go over. Please take a moment to read our code of conduct. We ask that you be kind and respectful to everyone, including our speaker. We want the reactors to be a place that everyone feels welcome. Please ask questions using the live YouTube or Learn TV chat. In the chat, I will also be sharing some links to the Reactor meetup page and monthly newsletters if you're interested in checking out what other sessions we have coming up. If you haven't already, please check in using our event check-in at aka.ms/reactor check-in with event ID 14315. Today's session will be added to our Reactor YouTube page in 24 to 48 hours. And finally, I'll share a link to our Reactor survey. If you have a few minutes, we greatly appreciate your feedback. And I will now pass it over to Sam.
All right. Hello, everybody. Today, we are going to be taking a look at GitHub Actions and how you can start automatically deploying your containers to Azure Kubernetes Service using GitHub Actions. The reason we really want to do this is because it gives us a way to have some core central source of truth for what our application actually is. Here we have what we've been doing previously, and we've been running a bunch of console commands to deploy this ourselves from our own PC into our production environment. So we're not going to walk through a lot of the same setup steps that we had previously. I already have a Azure Kubernetes service set up. Git node. So we already have our AKS cluster set up. That's already there. We also have a container registry that also exists and has our images in it. What we're going to be focusing on is how do we get the current state of our application into that container registry and then pull them down into AKS so we can actually run the latest thing. And this way, whenever a new change is merged into the main branch of our repository, it's automatically deployed for us, and we just constantly have a new set of the latest deployment, the latest application, and whatever else we're changing. Again, the advantage of this is that it's always something centralized. It's something anybody on your team can see, and it's easily version controlled and seen by anybody. You can't go and modify this locally on your own machine and get a different result because it's always going to be deployed from GitHub. So we're going to kind of start by just taking a look at what we have locally. This is basically everything we have. We have our .NET application, our Docker file, and then a series of Kubernetes resources. We can just deploy those manually using kube control, apply, and then the resources, pod.yaml. And this is going to create the resources just like we were doing previously. This is what we want to bring into GitHub Actions. GitHub Actions allows you to run specific jobs as triggers to certain activities in your Git repository. I have already added this repository to GitHub. It is here. So this is the current state of our application in Git. If you're unfamiliar with how to do Git, you can create a new repository from GitHub and start working with it that way. I'm realizing I didn't sign in, but we'll get to that in just a sec. So here we have all of the sources for our Kubernetes repository. It should have a deployment now. Control git deploy. And there's our deployment. We can get the pods from that and see what is actually running in our container from this, or remove it. Actually, no, let's keep it here. And this way we can actually override it with what we're going to do in GitHub Actions. GitHub Actions is more YAML. So if you've been doing Kubernetes stuff, you should be familiar with YAML. It is basically the configuration for everything in your infrastructure. It defines what is expected in your thing. This is our deployment and our service. It's separated by this triple dash. And so GitHub Actions are going to exist in a GitHub repository. So .github is the name of the, oops. There we go. I recommend doing this from the CLI, but I didn't do that. Anyway, and then there's a workflows folder. Just to double check, should be workflows. Yes, okay, cool. So this workflows folder is going to contain any number of workflow files. These are just YAML files that define what your thing is going to do. So let's create a deploy to aks.yaml file. The name of this file does not really matter. It is going to be referenced later in GitHub, but you don't really need to worry about it. So what we're going to do is actually define how we're going to deploy this thing. So let's do that. We're going to create a name, deploy to Azure. This is the name that is going to be displayed in your job. I've already been using this, so there's going to be a few previous jobs just when I was testing this, but it should be fine. And then the next thing you need is a trigger. This is going to be the trigger that is actually going to say, run this job. It's actually going to tell GitHub to go and actually create a worker to execute your job. In this case, we want to react to pushes. So we can just do on push like this. And then we need to specify our jobs. Our jobs is a set of jobs. These can be any number of jobs. They will be executed in parallel. If you just deploy them like this, typically you just need one. We're only going to be using one in this example. There's also going to be a number of different things that we're going to be kind of throwing here. If there's questions, highly recommend just leaving them in chat and we can kind of cover them as we come up. Because there might be some things that I might gloss over that may not may not be mentioned as much as you would like. So the next thing we need to do is give our job a name. These jobs can be named anything. It needs to be a valid key, a YAML key. So we can just call this our deploy job, which is going to deploy our container. And what we want to do is specify where this runs on. I am going to specify Ubuntu latest. You can see it's suggesting a few other things. If you're curious what this means, there is a set of definitions out on GitHub that you can actually go and look at for what is in the image that we're talking about. This is not the one that I want to look at. But there are a number of different images you can use. GitHub Actions supports Mac, Windows, and Linux-based environments. So you can run any of them. Let's look at Ubuntu 2004. And this includes a list of all of the currently configured things for that image. So you can actually explore what is already available for you in that VM that GitHub is going to give you, and sort of what is pre-configured. You can browse through this if you'd like. It's just available publicly on GitHub, but this is the image we're using. So going back to our code, we want to define a series of steps. So jobs have a set of steps. While jobs are run concurrently, steps are run in sequence, and they define different things that are going to happen in that job. These are also defined publicly in open source in most cases. So in this case, our step has a series of uses. So this is going to define what we're going to do. It's basically just a list of the things that you want to do. So the first thing we want to do is check out our code. This string is going to be the name of the action followed by a label. This label can be either a branch, in this case master. It can be a tag, so v1 or whatever your tag might be, or it can be a commit or a git SHA. And this can point you directly to the specific commit that is the version that you want to use. These action steps can be defined in two different ways. They can be either TypeScript, or they can be Docker files that are running their own containers to do some job. I found most of them happen to be TypeScript. There's a very nice SDK out there if you want to learn how to write your own. But typically, you're always going to start out by checking out the current state of your code. So actions checkout. What we can do here is actually, because this is all mostly open source, you can go and grab where that action is actually out on the internet by just grabbing the first bit, the action/checkout, and opening that. So if we go here, we just go to github.com/action/checkout, just pasting the name after that. We will actually get the defined set of the action, and you can go and browse, find the specific name or version or whatever you're looking for, and actually get that. There's a whole bunch of usage information, everything you want. Most actions are going to follow this format, so you can find a lot of what you were looking for just by following through this. Yeah, that is going to actually check out our code. That's like step one. The next few things we want to do is actually integrate with Azure. Because we've checked out our code, the main thing that we're trying to do here is build a container. The first step that we're going to look at is build a container, push it to the container registry. We're not going to deal with Kubernetes yet. That will come in just a sec. But this is sort of the first step. There's 3 total steps to this. So the next thing we're going to do is just use uses. And then this is an Azure defined function. So Docker login at version 1 with is going to allow us to provide a bunch of parameters to this configuration. So we can actually define a bunch of different things that we want to do. So I need to provide a login server that's actually going to say, where is this thing that we want to go to? And we want to go to Sam's cool containers .io. There we go. And then the next 2 things we want is a username and a password. This is actually going to allow us to sign in. So let's do this. And this fun syntax is going to allow us to insert special values. So you might use this for environment variables, or in this case, we're going to use this for secrets. The username and password are going to be coming from a service account. We haven't created the service account yet, but we need something to log into our container registry with. And so what we need to do is provide the credentials here. Secrets are the way you want to do that. You could just type the information here, but this is a public GitHub repo. If we put private information in this, anybody is going to have that information. We probably don't want that, because what this is going to do is have permissions to push containers into our container registry. If we just publish the password and username, anybody can push their own containers into our registry or overwrite our existing ones, which if we're deploying that to Kubernetes, means that they can actually overwrite the container in Kubernetes, because they can push the container that overrides what we have. Kubernetes will pull that new container and start running it for them. And we probably don't want that. So what we're going to do is have a username and password defined in secrets. And I will need to log into GitHub to do this. So that will take just a sec. But here are the names of them. The things preceded with secrets are your secrets defined in GitHub. And we want a registry password. There we go. And we will come right back to that. And then the next thing we want to do is actually, now that we're authenticated with our container, we want to actually push this thing. So we're going to define a 3rd step that is actually going to push this. But instead of using uses to actually run this thing, we just want to run some code. We already have Docker installed on this image, so we don't need to install anything. We don't need to run any special action or anything like that. We can literally just pipe in our own code, our own scripts to run this. So I'm just going to do a Docker build and tag it with the tag. So Sam's cool containers. Let's do Dockerized. And then we're also going to insert some special values here. And I'm going to tag it with the GitHub SHA. And so this SHA is the SHA of the commit that we passed in. What this means is that every single image we push is going to create a new tagged image related to that specific SHA, which means from the commit SHA, we should be able to pull a specific image related to the code's state at that point in time. We could use latest, but that probably isn't what you want to do. You're going to end up with a bunch of extra stuff, and it could mean that if you update latest, but you don't update something that is pulling the latest version, you might get something else. So this will give us something that is a unique and tied to that specific SHA. You can find more information on GitHub's website about what these specific values are. So we need one other thing here, and that is actually going to be a Docker push. Actually push this into our container registry. So we want to define the name of our image that we're going to push. And this just needs the exact same GitHub SHA. And so what this is doing is building our image. We already build from .NET. So our image is 2 layers. It builds .NET, restores everything, builds it, and then pushes it. And then here, this actually creates the image that we're going to run and actually runs our website. So in this case, we're just running some basic ASP.NET thing that says hello world. That's all that this should be doing, is building an image and publishing that to the container registry so that we can constantly have a reference to that. So if we go back here, this is our new job. This should be everything that we need in order to run the job. Problem is, two of these things aren't defined. In my registry or repo, they actually are, but in yours, they won't be. I've already predefined these, so this works. But we're actually going to walk through creating the service account, something that I'll create and then destroy to avoid leaking some fun things. But we will actually be resetting these. So I need to actually log into GitHub because I forgot to do that before starting this demo. So 1 second. But what this is doing, is kind of going back and talking a little bit about this, what this entire process is doing is setting up a push-based action that when a new change is pushed into this repository, it's going to trigger a job and run that job in order to automatically push something into a new container for us with whatever the credentials we provide are. So we actually need an account that is going to do that. And I have lost my authenticator app. There we go. Cool. There we go. Thanks. All right, cool. We have fixed it. Let's do that and go over to our demo. There we go. Cool. All right, we're back. Awesome. Anyway, we need to actually define what we're going to do. So if we go into our project settings, you may not have access to all of these. If you are working on some repository with a team and you are not the owner of that repository, not all of these options are going to appear to you because some of them are restricted. But for me, it's my own personal thing. I would recommend testing this in a personal repository just so you can actually kind of explore and tinker a little bit. But what we're going to do is look at our secrets. So in this case, I have a few already predefined. Been working with them since 4 hours ago. If you need to create a new one, just create a new repository secret, give it a name and the value. In this case, we defined the name as registry username and registry password. So those are the two that we need to go and update. So if we go here and grab our secret name, go back and grab our registry username, registry password, click update, we can provide a new value. You cannot go and see previous values. And when GitHub Actions actually prints the secrets value in the console output, these will be masked. So you will not be able to see what the secrets are unless you explicitly print them out, but don't do that because then anybody can see them. And that kind of defeats the purpose. So if you end up pasting your username into some place that is plain text, just regenerate that service account's username or password. Username probably not that big of a deal, but the password is a big deal because then access. So we need to update this, but we don't know what to update it to. We don't have a service account to actually do any of this. That's not actually strictly true. I actually do have a service account to do this. So let's work with that. Let's do Azure Active Directory. Make this a little bit bigger. There we go. Azure Active Directory Service Principal. Create for our back. And we need to give it a name. Let's call it the Actions GitHub Actions push. So just an action that can push things. And you don't actually need to explicitly give it a role, but this is a default in the thing. But you can also provide the role of contributor, which will give it read and write access to most resources in your service. Then we need the SDK auth. And this part is something that you typically should not show to people. This is going away after this demo, so it's probably okay for a bit. But you should not show this to people. That's bad. So this is going to create our service principal. We should get a list here of everything that we need. What we want is the client ID and the client secret. So the client ID is our username. So we can update the secret with that. And then the registry password is this. There we go. So that updates our two secrets. And then the other thing we need for later is the Azure credentials, which is going to be that full block. I'm just going to do this now. We'll get to what that actually does in a bit. But what this is intended to do is provide us those secrets so that we can actually authenticate as this service principal to Azure. Now we can actually do some of the fun stuff. So we have this. It should just work, unless I've screwed something up, which isn't unheard of. So let's deploy this. So we have this entire thing. Let's just commit it. Add GitHub Actions, and we will commit this. And now everything is committed. It's all local though, so there won't be any updates to GitHub Actions. We won't see anything out here. If I go and look at what's happening, nothing's changed. That's expected because we haven't pushed it yet. Kind of covering that just as a good thing. I see this a lot where things get committed and then not synced. The easiest way I've found, just click sync. This will pull and push your changes to the name of the branch. We're working directly off of main, so you probably don't want to do that. But for just setting it up, this should be fine. So we've pushed that. If we refresh this, we should see a few things happening. First, GitHub Workflows appears in our repository. The other thing you'll see is this fancy little yellow dot. This is showing that checks are currently in progress. So we could click details to go and see the deploy to Azure deployment details, or we could just go to actions and look here. And this will show you all currently active running workflows in your entire repository. So in this case, you can see we have one. Ignore the ones below here. Those are all extra things, previous tests. So add GitHub Actions. You can see we have a deploy. And then here is each of the steps we defined. So in Visual Studio, in our YAML, you should see each of these defined. We have our checkout action here. We have our login. We have our build. And then we have some post actions to clean up everything. And so this is what is actually doing it. If you want to see some of the logs for what was happening, we can expand this and see everything that happened in this container build. So that is our logs for our container. This should be public, so you should be able to go out and grab this if you want to. I don't know why you would, but there's a bunch of extra fun stuff going on there. And so the fun stuff should mean that we now have out in our cool containers portal, we should have a new image here. There's a bunch of SHAs here. What we're looking for is the one that is tied to this number. You can see Docker build has this extra string attached to it. So instead of Docker build GitHub SHA, it's actually Docker build tagged with a tag of 942A06 and a whole long mess of string. That is the commit SHA. That is the commit, or a SHA, a hash tied to the commit at that point in Git. So this should be a relatively unique thing. And that means we can go and look here. And here is the container we pushed a minute ago. And so if we want to pull that, we can. The thing is all of this is happening out in the cloud, so we don't have a local version of this, but we can go and grab it. So if we clear all of that and do a Docker pull, Sam's cool containers dot Azure CR.io Dockerized tag. We should be able to just pull this image down. And I'm not authenticated with that container. Okay, never mind. This will work. I don't know why it's not authenticated. We're going to move on because this was sort of a side note. But anyway, you can pull the container down. It should work. Anyway, now we have our container here. It's something that you can actually grab and use as a point in time. So this container is what was in our GitHub repo at that specific point in time. Kind kind of an important thing because it means that you can actually go forward or go back to kind of work with these two things. So we have this. Let's actually push this into Kubernetes. That was why we were adding the Azure credentials. My tongue is getting tied. So the next thing we want to do is kind of add those extra steps that are required to get that into Azure. So we have a container. It's pushed into our container registry, but how do we actually work with this? Let's not work from that file. There we go. So let's add 2 additional steps. The 2 steps we're going to add are going to set the context of the Kubernetes cluster we're working with. And then the next step is actually going to deploy that into Kubernetes. So these are using some Azure fun things. So we're going to do uses. There we go. Our Azure AKS set context at v1. And so this is an image out here. Let's just take a quick look. github.com/blog. There we go. And so here is what this image is, or this step is actually doing. You can see there's a bunch of extra stuff to actually do here. Not so much in this one. In the next one, there's a lot of different things you can do with it. We're kind of scratching the surface. This is intended as sort of an introduction to this whole DevOpsy CI pipeline stuff. So we're not going super deep. We're just kind of trying to show the basics of how all of this works. So that is that step. Lots of that's. Anyway, we need to give it a few bits of information so it actually knows what it's talking to, because this, like the Docker login we were doing previously, is going to be actually talking to Azure to figure out how do I connect to an existing Kubernetes cluster. That's what we're trying to do here. We're trying to give it an access to our Kubernetes cluster so that this job can push deployments or other resource files into our cluster and actually get them running. So that's what we're going to do here. Find our with credentials. Another secret, the one that we defined previously. So here's our secrets. Azure credentials. There we go. And then we need 2 other things. We need the cluster name. Is Sam's Cool Cluster. There we go. And the resource group, which is just demo. Why not? So that resource, spell that right. And so this is going to give the credentials for that service principal. It's going to give the cluster name that we're actually going to connect to. So this should be the cluster name of whatever your Kubernetes cluster is named, and the resource group that it lives in. And so with this information, it should be, or we should be able to actually go out and connect to our cluster. And then we need to actually deploy the thing. So this is the fun one. There is a lot of configuration here that you can do. We aren't really diving too deep into that. We're kind of focusing on the GitHub Actions and the deployment pipeline, but I highly recommend checking out what you can do with this image. It's pretty cool. So with, and then we need a set of manifests. And these manifests are going to be the resources we want to actually deploy. So this can just be a list of different things. In this case, it's just our resources here. So we want resources / pod.yaml. You can provide additional files here. So if we want to deploy our job, resources / job.yaml as well. And so you can just keep adding things here to deploy if your repository has multiple different things. Also, you can add multiple YAML files to the workflows. As long as they have a unique name, it will be fun. So you can just keep adding additional things. What else? We need a set of images now. So what we're going to do is actually provide an override, because this pod here actually specifies what image to use. Dockerized v1, which is out of date or not the latest in the repository. It is not what is most recent. So we need to actually provide something that is related to what GitHub built, because this resource file doesn't actually have a reference to that. So this step provides special stuff for you to override that. And so we can just provide the specific image we want to use with Sam's cool containers dockerized. And let's tag it with our GitHub. There we go. And type. There we go. And so this is actually going to say, deploy to Azure this resource with this specific image overridden inside of it. And so we've logged in, and now we're saying we want to deploy this thing. So let's push this to GitHub and see what happens. And this would be a good chance for questions, because this bit takes a bit, because it has to actually push to Kubernetes, and we're going to be waiting for a service to start. So there is inherently just a bit of waiting in this process. So deploy to AKS. Cool. And so if we sync this, we should end up with our changes out on GitHub. And we should have a new job running with the container name of like 5B something. So let's go to our actions, put AKS. And you can actually see this is getting a little bit longer here. This is going to actually show what's actually happening. The long step is typically the K8's deploy, but that changes. Again, these jobs can get as crazy as you want them to be. You can keep adding things to them. There are restrictions eventually, but you probably aren't going to hit those. And typically, you're going to run into them more for private repositories than anything else. So there is our deployment. It should have run. So if we could control git pod, what happened? We have a running pod that was started 17 seconds ago. So now our pod has been deployed from GitHub. We didn't run any deployment actions, and it's just automatically out there. Is there documentation on the verbs in the YAML file? Yes, there is a fantastic file called workflow syntax for GitHub Actions. And this talks about everything you could want. So if we go into here, there's examples throughout this file. So highly recommend going on it. But you can actually find like the name that we're using in this. That's the wrong thing. We'll get to that in just a sec. But the name that we're using up at the top here, you can find documentation on that. Everything else, there's a lot. It's not a short thing by any means. But most of this you probably don't need to use unless you're specifically looking for it, which is kind of handy. This also links out to events that trigger workflows, which is going to walk you through the different events that you can actually trigger your workflow off of. So in this case, when somebody forks your repository, or somebody stars it, or a pull request is opened, or maybe an issue is created, you can do all of these things, and all of them can interact with your different GitHub actions. So for example, if you want to add some specific comments when somebody opens a new issue, for example, you can do that with actions just using some of the issues events. We'll get into a little bit more about what some of these things do in a bit, but this documentation is pretty good. And there's lots of examples here. So highly recommend just like opening this file and browsing it and being like, oh, that's interesting, and trying it. Worst thing that happens is you just revert your whatever commit you did. It's all source controlled. So the cool thing is if you screw it up, you automatically have a rollback because it's all in source control. As long as you have some safe state eventually, you can always just roll back to that safe state, and it should just work. And if you're kind of curious, you can fork the repository that I'm working from and kind of add your own stuff to that to get it to work. That should work as well. I haven't actually tested that, but anyway, yeah, this stuff is cool. Anyway, we ran our thing. It's done. We have our deployment. What am I doing next? Right. So first, one thing we should cover before we actually do this. This probably isn't how, well, we'll get to that in a bit. Sorry. Kube control, git service. Let's see where we're at. We have an external IP. As we've learned previously, this doesn't always mean that your service is immediately accessible, but we should be able to hit this and get hello world and actually get our service back. So let's start playing with this. What we have now is something that automatically deploys any code change to our GitHub repository to this Kubernetes cluster. There's a few problems. First off, this triggers on any push. So what we can do next is let's create a working branch so we can actually get some work done. So let's do doing some work. Make it really clear so everybody knows. And yeah. Then let's change what we're printing. So we do hello world. Let's do hello Azure. Just to kind of poke around. We're learning everything. We just want to see what's going on, figure out what's actually happening in our repository. So let's finish for the day, save our work out to our repository, and just to sketched up some ideas. Sure. This is all kind of intended as an example. This is an example project. It's very, very lightweight intentionally. But if we publish this, we're going to end up getting a new message and our production endpoint from that IP address that we created with the service. And that's probably not what we wanted. Once this finishes building, we should be able to just kind of demonstrate that. So let's go back to our actions, sketch up some ideas. We now have an action triggered, but we're trying to deploy the thing. So we are deploying some random work that anybody on the team is doing. This is typically not how you do continuous deployments. So in this case, we're still building the image, but eventually this is going to deploy and end up in our cluster. So we probably don't want that. What we want to do is kind of filter this down. So we're going to kind of start doing that by adding some extra changes. So let's look here and look at this push job again. There is some stuff going on here that we probably want to switch a little bit. So with on push, we actually want to add some parameters to this, like set of branches. So when you push to these specific set of branches, we're going to push. So if we go to, say, main and say only pushes to our main branch will trigger this job. This will prevent our working branches from deploying too broad. You can also use some protected branch features in GitHub to actually tweak this even further. So again, this is a feature that you probably won't have if you're just a contributor to your project. If you are an owner, you probably can configure these. But you can create protected branches in GitHub and prevent people from pushing directly to your main branch. And so what this will do, if we add a rule here, is say require a pull request before merging. This means that people who try to push directly to it, can you fork this GitHub repo? Yes, you should be able to. It's at runemake2/dockerize.net. I don't know the best way to get a link to that, but yes, you can. And it should just work. You will need to configure the secrets and stuff. And yeah. I'm trying to think if there is any side effects to that. And I think it should work. If it doesn't work, let me know. And I will figure out a solution, because if it doesn't work, I'd be curious how to fix that. Anyway, protected branches. You can protect your branches in a number of different ways. In this case, we're just going to require a pull request before merging into main. But you can do all sorts of different things, require specific approvals from owners. So for example, a specific lead on the project needs to give it the okay before it ends up in the main branch and gets released. You can configure this in any way. It's kind of up to you what makes sense and what sort of fits your needs. But in this case, we can kind of just trigger that. That's sort of I guess, important thing. If we're having our main branch be our released stuff, you probably want some protection on main, so somebody on the project doesn't just automatically push to main by accident for like some quick fix. And now you have unapproved, untested code running in main. There's another issue too. Our project doesn't have tests. So this gets a little bit weird. but you probably want tests before you start deploying things into your production environment. So typically, sometime after building your containers, but before deployment, you would want something to actually do this. No, this is a Linux-based .NET project. So in a previous episode, we walked through and kind of built this. This is using .NET 5, but it is using Linux environments. So you will need a Linux environment. That's why we're building this in Ubuntu. If you're using Windows, I think it should work just fine, and you should be able to build that. You just need to make sure that you don't use your Ubuntu latest, that you actually use Windows latest or whatever Windows version you need. I believe Windows containers are a little bit more picky about which version you use. So if you're using them, you probably know better than I do. So that's sort of what you'd want to do, is just make sure where you're running your job is selected correctly. An important note here, each of these jobs, so in this case we have one, just the deploy task, can run on different environments. So you can have a job that runs and builds your Ubuntu environment, and one that runs your Mac environment, and one that runs your Windows environment, and do each of those independently. So if you want to do all of those different things, that's possible, and you can do it. I would recommend checking out matrices if that's something that you want. It can simplify a lot of that. Yeah. What else? Kind of went on like 6 tangents there, but that's actually good. It means we're hopefully learning some things. So we've deployed our thing. I think that's where we were. Hello world. Now it says hello Azure. Cool. We just deployed our working branch to our Kubernetes cluster. We don't want that. Let's get our fix pushed so that doesn't happen anymore. So we've now specified that this is only going to happen for branches that push to main. There are other things that you can do here to restrict this. We're restricting based on what branches you push to. You can also do, I believe it is paths ignore. So for example, you could do paths or paths ignore, branches or branches ignore, if there's, depending on what fits your job. But for example, if we want to ignore documentation changes and not run this deployment task and create a new container image when there's markdown file changes only, we can do a path ignore to ignore that when markdown files changes. And this would mean that only the job would only run when something other than a markdown file was changed. Those are kind of nice if you have like specific like documentation generation or something like that. You can use this to get ahead of those and not run like a really long test if you have a markdown or you have documentation changes. Like you don't just end up burning a bunch of actions time. One of the things for public repositories that you won't run into typically if you're just running this yourself, but you might on a larger team project, is that there is a limit on the number of concurrent builds you can have. So if you're very long running builds, like you have a ton of tests, you might want to consider something like this to tweak those down or figuring out some other way to run more of them. So anyway, there. That was a really long-winded way to add 2 lines of code. So we have our branches. We're only going to run this on main. Let's push this to our repo and do limit push job to main branch. Cool. Make sure we have good names for our commits so that people actually know what we're talking about, and sync those up. And we should have those out. That's the wrong thing. There we go. So we're back here. Cool. Here is our job. You'll notice it did not run. This is kind of an important thing when working with GitHub Actions. It uses the YAML defined for the jobs at that current commit. So what that means is if you are making changes to the commit or the job as you're running this thing, these will start popping up into your actions. So we limited it so it would only run on main, and our new job did not run. So this one is 8 minutes old. So that's kind of a nice thing. It's kind of it's been weird. Took me a while to actually learn that. Anyway, let's actually pull this in. So this is in our main branch. Just compare pull request, doing some work. Cool. Pull this in. And now we've actually merged this into main. So this should trigger a new action. Another thing you'll note, nothing triggered here. That's good. Actions. Nothing triggered there either. That's odd. Oh no. Sketched up some ideas 9 minutes ago, deployed to Azure. Huh. Why do we still have a pull request? Doing some work. Did I not merge? Oh, hey, you have to click the button. All right, cool. Well, that. All right, it's one of those days. Cool. We now have our action running. This is actually going to build that new image and push it out to our Kubernetes service. We shouldn't see any change because the code change was already pushed because we did that first. And that actually pushed before we restricted when the job would run. So now we have this thing that is merging, should end up pushing our commits, and we'll just have that running out there. Some other things to call out. There is a fun way that I mentioned, for example, commenting on different things in your jobs. One of the ways you can do that is with the GitHub token. So this is covered up. This is our GitHub token. I'm just going to type it here because there's actually not a use for it in this event. But in this case, we have GitHub token. This is actually something generated for you by GitHub and provides your GitHub Actions with access to your repository. This allows you to, for example, create new commits, create pull requests, or make comments on issues. So you can actually use this to do a bunch of automation over your entire repository. So if you need actions that kind of interact with other parts of your GitHub repo, that's something to look into. Yeah, that's pretty much it. We have one other thing that I kind of wanted to add, and so we will do that. We've merged that, so let's switch back to main, pull this new stuff down, get all of our changes, and let's actually, before we do anything else, let's scale up our job. So we have one thing here. We have one replica. We can actually just change that and increase that to 5. In this case, we're still going to rebuild our container image, so it takes a little bit more time. We're not super engineering this thing. Again, you can restrict it, but we're not. We're going to add 5 replicas instead of just the one that we previously had. So in this case, we can do this. Scale up our cloud app. Cool. Push this. Add our changes. Scale this up and deploy this. I'm pushing it directly to main. Again, I talked about protected stuff. You probably don't want this. We're allowing it because why not? It makes this demo go slightly faster. So that will eventually cause 5 additional replicas to be added to our Kubernetes container. So we can actually modify and work with our environment through this. So we have all of these sets of when these things were changed, what was new, when did this get added. All of those different things start being possible because we're actually tying all of this to Git. If I don't like having 5 replicas, I can just roll back the commit and go back to something previously. We can just go to a different point in time and grab that. We don't even it's not just console commands that you're working with from wherever. This isn't something that is based off of some intuition that you feel as much. It's something that you can actually sort of describe and document so that the rest of the team can see and review what is actually happening in your environment. You're not just in a console typing away and hopefully spelling everything correctly. And if you do spell something wrong, you can just go back. That's the cool thing about all of this. If you start digging into DevOps stuff, you are probably going to see some talk of Git Ops, which is somewhat new. At least it's new to me. That is something that we're not covering. That is kind of way outside the scope of this. But Git Ops allows you to actually do a lot of what we're doing here, where we're automating our application, but it allows you to do it for your infrastructure as code. So imagine having your container registry and all of the settings for that and your Kubernetes registry defined in your Git repo as well. So that way, if you wanted to add additional nodes to your node pool, you could scale your entire Kubernetes cluster up from Git. That is sort of like the next long-term step. If there are other questions, it would be a good time for them. The final thing that I think I wanted to call out before we get to those is this example is probably fine for one-person projects. There are some hiccups that are going to exist here that could cause issues if you're doing this in a larger person project that kind of would draw this out longer than the time that I have. But we should talk about them a little bit. So in this case, when code is merged into main, we are doing our deployment automatically. We should have tests here to make sure that this is working. And even if you have tests, even if you create a pull request thing, so if we can do that real quick. Let's just set this up super fast. So pull request, sure. I'm going to ignore most of this. Delete that because we don't need it. And this would be, I think, pull request. So whenever a pull request is open to main, we would run this job, and this would build our job and push it, and we would be able to run it and do all sorts of fun things. Even if all of these run, like say we had, I don't know, .NET test, for example. Even if all of this run and passed, it would only run and pass from the last time you updated your pull request. So if you have two people working on it and one opens a pull request, all of their checks would run and pass. And then if somebody else opens a new pull request, their checks would run and pass. But if one of those projects merges in and it doesn't create a conflict with the other person can just pull their changes in as well. But the combination, the delta between those two wasn't tested until it ends up on the main branch. So you do want tests in your before your deployment. And typically after you've deployed two, you're going to want some tests to determine if this actually worked. If our app becomes unhealthy, we probably want to roll it back. That's why I was saying there were some cool things with this K8s deploy. It allows you to kind of do some of that. Go check out the docs. Anyway, the final thing that I kind of wanted to talk about is GitHub Universe, which if you're super interested in GitHub stuff or Git Actions, GitHub Universe is next week, I believe. Yeah, next week. So if you want to learn more about this, that would be a good place. There's a bunch of talks about GitHub Actions and other GitHub related things. So yeah, that is mostly it. I don't see any questions. So that should be everything.
All right, thank you so much, Sam. Just a quick reminder, we've shared some links in the chat. There is a link to the series page for this session, and I will share that again shortly. So if you do want to watch past recordings of any of the previous sessions or sign up for the next one, you can do so on that page. I will share that again. We also have a link to our Reactor newsletter if you want to sign up for that and get a monthly newsletter of all our upcoming sessions. And then finally, there was a link to our survey. If you do have a moment to fill that out, we greatly appreciate your feedback. And actually, I shared the wrong link, so let me share that again to the survey. And we give it a couple more minutes or seconds to see if a question comes in. All right. Sam, anything else before we go that you want to mention?
I don't think so. I would say just go and try this. The cool thing with this is you can actually go, I mentioned forking this repository, but you don't have to fork my repository. The cool thing with GitHub Actions is it's public for the most part. You can do this with private repos, and that's a whole different thing. But if you're looking to learn more about public things, you can find another project that is using this. Just go to GitHub. This isn't actually the right search for this. I don't know what is. What? All GitHub. Cool. You can just search for GitHub workflows across GitHub and find repositories that are using them and see what they're doing with them. It doesn't need to be my repository. It doesn't need to be any specific repository. But because it's public and you can go and grab things, you can create your own actions. You can find actions that exist. There's a huge number of them. Or you can just find workflows that people have written for their .NET app or their Node.js app or their Python app and figure out how to do all of that. So lots of different options if you're looking to learn more about GitHub Actions. So that's the last thing I would say.
All right. Thank you so much. And thank you, everyone. And hopefully we will see you all next week and have a great rest of your day or evening. Thanks, Sam.
Thanks, everyone.